Hi folks, this is Calc 1, Checkpoint Quiz 12. We're given a function f of x. We're asked to find the open intervals over which f is increasing and the intervals over which f is decreasing. We're asked to locate any relative extrema. Okay, so if I'm given a function f and I'm looking for where it's increasing and decreasing and trying to find relative extrema, I need to know f prime. So we need to make a sign diagram for the derivative. So when I take the derivative of this, if I substitute a value for x, the last thing I would do is multiply these two quantities together. So I'm going to have to use the product rule. So I'm going to take the derivative of the first factor times the second plus the first factor times the derivative of the second. So the first one here is just the standard power rule. It's going to be 2/3 x to the 2/3 minus 1. And the second factor we leave alone. 2/3 there. The derivative of something to the 1/3 power is going to be 1/3 times that something to the 1/3 minus 1 power times, chain rule kicks in to take the derivative of what's inside. So I'm getting 2/3 x to the minus 1/3 times x minus 3 to the 1/3 plus 1/3 x to the 2/3 times x minus 3 to the minus 2/3. And the derivative of x minus 3 with respect to x, that's just 1. So that's not going to contribute anything there when I multiply it. Alright, so now what I want to do is factor out common factors. So as far as the fractions go, I've got a 1/3 I can factor out of each term. And now I got to factor out a power of x and a power of x minus 3. And remember, when you factor things out, you want to factor out the smallest exponent. So let's write down what that's going to be. I'm going to have 1/3 x to the minus 1/3 versus x to the 2/3. Negative 1/3 is smaller, so x to the minus 1/3. And then it's going to be x minus 3 to the minus 2/3. Now remember, when you factor something out, it's the same as dividing by that thing. So factoring out the 1/3 is really dividing by a third, so it's going to be multiplying this by 3. So it's going to give me a 2 then. Factoring out x to the minus 1/3 means I'm dividing by x to the minus 1/3, which means I'm multiplying by x to the positive 1/3. So that's going to be factored out and give me a 1. Dividing by x minus 3 to the minus 2/3 is the same as multiplying by x minus 3 to the positive 2/3. That's going to give me an x minus 3. Here, the factored out to 1/3. I'm going to be multiplying x to the 2/3 by x to the 1/3. That's going to give me an x to the 3/3, which is x. And I've completely factored that out. Give me a 1. Now I'm going to put things in the denominator that belong there. So the 3's in the denominator. This is going to be x to the positive 1/3. This is going to be x minus 3 to the positive 2/3. And let's look at our numerator here. I've got 2x minus 6 plus x. That gives me 3x minus 6. So I can actually factor the 3 out and cancel it. And so I get, for my final answer for the first derivative, x minus 2 over x to the 1/3, x minus 3 to the 2/3. Okay, so now that we have our derivative, we're going to look for the critical values. So we're looking for where the derivative has domain issues or where the derivative is 0. So let's look at where the derivative does not exist. So what could possibly go wrong here? Well, we have fractional exponents. Since the denominators of the fractional exponents are odd, that means we have odd roots. So we have cube roots in here. So the radicals aren't going to give us any trouble. But what could give us trouble is if either of these factors down here are 0. So f prime of x doesn't exist. We would set the denominator equal to 0. And you would go through the usual algebra machinations and get either x is 0 or x is 3. The other thing we then look at is where f prime of x is equal to 0. So we set this thing equal to 0. And we're sort of implicitly assuming here that x is 0 and x is not 3, so this is defined. And so doing that, I can multiply both sides by the denominator, and this gives me x minus 2 is 0, so this gives me the critical value x equals 2.